Welcome to the part 5 of this series of deep learning. So the dot product and the vector dot product is one of the most important operation in all applied mathematics. Therefore, the dot product is also one of the most important mathematical operation in the deep learning. In this video, you will learn various notation in the dot product, how to compute a dot product in vector and matrices, the application of the dot products. So let's see the various notation of the dot product. So there's like a lot of notations here. Sometimes it's depicted as a dot b, which is always equal to a comma b with the little angle bracket. So this one here is a transpose time b, is the most common one which you often seen in deep learning in the upcoming videos. So this is actually a mathematical definition of the dot product. It is actually summing over an element in a vector a and b, and for each corresponding element I, we multiply those elements together and then sum over all those individual multiplication. So this is actually I can say the general mathematical definition of dot product. In the next slide, I will explain how a dot product is working for a scalar product. So if you see here v and w, it's actually a vector v and w. So as I told you, this is common notation. If we apply dot product on these two vectors, this is how it's work. It's work like 1 times 2 plus 0 times 8 plus 2 times minus 6 plus 5 times 1 and minus 2 times 0. So after computing all this value, it actually give us a minus 5 as a result, as it's just a basic mathematical multiplication and addition. So please keep in mind, whatever your computational is, even this is 2 by 2 matrix or 3 by 3 matrix, the dot product is always give you a number as a result, like anything like 5, 10, anything depend upon what your computational is. And another important thing is the dot product is not defined for any two vectors. It's only defined for two vectors that have the same numbers of numbers, like same dimensionality, for example. So I will try to explain in the next slide what I mean by that. So if you illustrate this example here, it's actually the vector, this one is actually 1 times 5 and this one is 1 times 3, let's say example. And if you try to actually compute a dot product in these two vectors, it is impossible because it have to have the same numbers of numbers and same dimensions. If you try to compute this one, it's actually things something like that: 1 times 2, 0 times 8, 2 times minus 6, and where the 5 should go with. So to solve this problem, either you can put 0 here or you can reduce this vector to only 3, 1, 0 and 2. So this is what you must aware of when try to compute a dot product, because when we are going to do in machine learning or deep learning, so the shape of the data must be matched, otherwise it always give you an error. So that's why it's very important concept to learn before actually diving into deep learning. So in the next slide, let's see how we can perform dot product on a two-dimensional data, we can say matrix. So this is something that we are going to be doing when we are learn about CNN or convolutional neural network. The procedure is exactly the same, we just have more number to keep track of. This is exactly same we are going to do in CNN. All right, so this is work same as 1D dot product is like 0 times 1 plus 3 times 0 plus 2 times 6 plus minus 3 times 2 plus minus 3 times minus 1, something like that. At the end of every computation, the result must be a single integer. So this at the value, this is actually the final value of the dot product. So just keep in mind, the result of dot product, any matrix, any data is always be a number. Another important thing to keep in mind, the dot product is defined only between two matrix or two vectors that exactly the same shape or dimensions. All right, now let's switch to the Python. I will show you how to implement the dot product using NumPy and PyTorch. It is very straightforward. So here we go. So the very first step is to import the library. So import NumPy as np and import torch. All right, oh sorry, it's torch. Okay, we will have to create a vector. We can say nv1 is equal to np dot array, and let's say 1 2 3 and 4, 1 2 3 and 4, and we will create another vector. We can say nv2 is equal to np dot array, and here I pass -1 5 -9 and 3. all right, let's compute the dot product on it. So basically we can compute a dot product by two separate methods. So the first method is using dot function, and the second method is using sum. So the dot function is pretty straightforward. Is actually say print np dot, and inside dot function we just have to pass the two vectors nv1 and nv2. It actually print a dot product for you. And the second one is print np dot sum function, where we're actually computing multiplication of the two vectors. So np multiply nv1 and nv2, sorry, nv2. all right, so if we run this program now, you will see -6 and a -6, which is the same result of the sum function and the dot function here. My preference is use dot function because it's like give you an idea what you're going to do, because it's likely name suggests as it's a dot function. all right, so let's see how we can do in a PyTorch. In the PyTorch we have to create a tensor. So tv1 is equal to torch dot tensor, and here we can say pass 1 2 3 4, and tv2 is torch dot tensor, let's say 8 11 -9 and 4, and let's compute dot product on tensor. So print torch dot have to pass. So can you please guess what we need to pass here? We have to pass tensors tv1 and tv2. That's it. So if we run this now, it actually get a tensors 19 dot. The tensor actually print the float value by default, even though we pass integer values here. all right, so this result is different than this one because we actually change the data values here. If we keep the value same, is going to be print the same values. all right, so it's your homework. You have to find the dot product on a two-dimensional array, and I'll say matrix, and two-dimensional tensors. all right, so now we have seen how we can actually compute a dot product in a Python and the PyTorch. So let's discuss the interpretation of the dot product. A single number that reflects the commonalities between two objects, between vectors or maybe matrices, tensors, and signals and images. So if you are coming from a statistics background, you might be thinking that this is a description of, for example, a correlation coefficient or the covariance coefficient. In fact, the correlation coefficient is nothing more than a dot product between two variables. That is what interpretation means, like commonalities between two objects. So let's see what are the applications of the dot product. So dot product is the computational backbone for many operations. It's actually the backbone of all these concepts like correlation, least square, entropy, PCA. For signal processing, it's used in Fourier transformation, filtering. You can read it out here. So this is the application of the dot product. It is very simple and straightforward. If you understand where you can use it, you can go more far away. So thanks for watching this video. That's all in this video. I will see you in the next video.